In this video, we're going to look at section 1.9, multiplying whole numbers, and there's really a lot going on here that we want to connect to them. So again, I think almost all of them will know that 5 times 3 is 15, but there's a lot of language here and a lot of interpretations of multiplication that we want them to familiarize themselves with. So here's some language that we use. So the numbers being factors, the result being the product. It's going to be really important when we start talking about GCF and least common multiple, that we use all of these phrases. 5 copies of 3 may be something you haven't used before, but we'll talk about that throughout the semester, especially when we get to fractions. So thinking of 5 times 3 as a group of 3, and you take 5 copies of it. So you could think of, if you have 3 of something, taking an image of it and then copying and pasting 5 times to get your 15. 5 multiplied by 3, 5 groups of 3. Also, we use all sorts of notation, and they need to be familiar with all of them and understand what they mean. And then we have context, and there's many, many ways to think of multiplication. Okay, here are 4 of them. Here we have a rate. Here we have an area or an array model. So let me just draw a picture of that. So we have 5 by 3. Okay, so pretend these are squares. And the area of this shape will be 15, and we'll be using this area model a lot. You could also think of this as an array of 5 rows of 3 or 3 rows of 5, and this helps to connect to commutativity, which we don't officially talk about until Unit 3. You're purchasing 5 DVDs at a cost of $3 per CD, so this is a good example of repeated addition. Okay, so again, when we get to the abstract notion of multiplication, we can think of these in any of these ways, but it's good to have these ways to think about multiplication to connect to the other ideas. So 5 DVDs at $3 per DVD means we'd add $3 to itself 5 times. And the first one, have no idea why I went in reverse order, sorry. Bernadette invites 5 friends over, 3 cupcakes per friend. How many cupcakes does she need? So she'd need 5 copies of 3 cupcakes. Okay, and notice that this one is different than 3 friends and 5 cupcakes per friend. Okay, so even though either way you multiply them, we have the commutative property of multiplication. The order doesn't matter. However, we do want them to be able to distinguish between these in a context. So this one we would say is symmetric. When you think about that utility room, it doesn't really matter what you call the length and the width. Okay, but here 5 friends and 3 cupcakes is different from 3 friends and 5 cupcakes. Here 5 DVDs at $3 is different from 3 DVDs at $5. And 3 miles per hour for 5 hours is different than 5 miles per hour at 3 hours. So you don't have to overemphasize this, but we want them to understand where the numbers go in the product so they can interpret this later, again, when it gets more complicated with fractions and decimals. And to use base blocks to multiply integers, we'll use these types of grids. Okay, and basically the distributive property. So you'd outline this to 14 and 23 on top. Okay, and sorry, my tablet won't let me draw on this. But so you'll make that rectangle, and then they can make that rectangle themselves with base blocks, and then we're going to break it into pieces. So let me draw this here. So 14 by 23. Okay, so if this is 14, we have a 10 and a 4. Then this is 23. This would be 10, 10, and 3. Okay, so notice these two 10s from the picture, it probably looks better. This would be 100. This would be 100. Okay, this is 3 and 10, so this is actually 3 rods, okay, or 30. This would be 4 rods this way, or 40. This would be also 10 by 4. So this was this 10 by 4, and this is this 10 by 4. So we have another 40. And then here this would be 3 by 4. So 4 rows of 3, which is 12. Okay, and this looks a lot nicer with base blocks. And we call it the extended algorithm. We have them add up all these components. So whatever this may be, 8, 9, 10, 11, 12, 322. Then you can extend that to, or connect that to the algorithm. 4 times 3 is 12. I'm going to write this a little bit differently. 3 times 1 is really 3 times 10, which is 30. 2 times 4 is really 20 times 4, which is 80. 20 times 10 is 200. Okay. Then you can show them the corresponding pieces. There's the 80, the 30, the 12. And then you can show them how our standard algorithm shortens this by combining these two. We do 2 carry the 1. 3 plus 1 is 4. That combines these. The placeholder, why we put the 0 placeholder there. 2 times 4 is 8. 2 times 1 is 200. And we combine these and add. Okay, so that's the idea, having them set this up with base blocks or a grid, okay, and not going directly to the standard algorithm, showing them how it connects to this area model.